Hi there. This is a summary of the lesson from November 30th and December 1st in this class. So we started a new unit on transformations, which really just means taking objects and changing them in some way, transforming them. And the first thing that we studied are translations. Okay, and these notes are on Schoology. You can go look at them there and copy them into your notebook. Translation just means to slide an object in a given direction, right? And I know that that's a little weird. Oh, look, two triangles. One is the original object, and then I translate it by sliding it along some arrow here. So in this case, we could, you can see that it's slid along the arrow in the diagram. But if I connect each of these corners, do you notice that the lines connecting the corners are all parallel to that arrow? So all the corners are actually slid in that same direction. And you get a new triangle that is congruent to the original object. It's the same size and shape, and it's in the same orientation. It's facing the same direction, right? It's still sort of sitting upright. It hasn't been flipped or spun or anything like that. And I have some documents here that I can show you what that looks like in real time, right? So you see this purple triangle, A, B, C. If I just grab point A, I can move it, and I slid that triangle to a different place, right? I transformed it. It's no longer in the same position. Therefore, it's a different triangle. That's what a translation is. I'm just sliding it around. I can go left, right, up, and down, and I get a new triangle. It's just in a different position, but it's always the same size and shape as the original triangle. It's a way to show that triangles are congruent. We even did a little investigation where I said, hey, figure out how to get this purple triangle onto this transformed orange triangle. And we figured out that, well, if I move it 5 units in the X direction, that made it go 5 units right. And then, oh, it looks like it's down 2. So I'll do the Y translation of 2. Oh, but wait, that moved it up. And so then we figured out maybe I should use -2. Yeah, and then it moved it into place. So we can see that those two triangles are congruent. And all we had to do is translate the original triangle to the image by moving it 5 units to the right and 2 units down. Okay, and we're going to do most of this work in the coordinate plane. And so then what we did after that in class was we looked at an example of a triangle like this one. And these notes are on Schoology. But I said, let's take this triangle and translate it 3 units to the right and 4 units down. And I know that given the chance, you could probably just say, okay, I'll just take each of the 3 corners, like corner C here, and I'll go 3 to the right and I'll go 4 down, and that's where C would be, right? But we put a little prime there. This prime, this little tick mark up at the top, it's like a single quotation. That's really says C prime, and prime means copy of. So you could do that pretty easily. But another thing that I wanted to teach in this class today was this idea of mapping your transformation. So a mapping is where you take your coordinates and you figure out, what do these instructions tell me to do to the coordinates? So if I want to move 3 units to the right in this direction, what am I changing about my original coordinate C? C was at 3, 3, and the new C is at 6, -1, right? Well, you can see that what I did was I added 3 to my X coordinate. And so when I write a mapping, it's like it's a function, actually, where I take my original X and Y coordinates and I do some math to them. So if I add 3 to my original X coordinate, I move it 3 units to the right. This is my old point here, and this is my new point here. And then if I want to move 4 units down, I would subtract 4 from the Y coordinate, because subtracting moves it down. So I'd do X plus 3 and then Y minus 4. And then we actually use this mapping on a couple of these points. So if I take A, which is at 1, -1, and I run it through the mapping, I would take the X coordinate, which is 1, and I would add 3 to that. I would take the Y coordinate, which is -1, and I would subtract 4 from that. I'm just using these as instructions. X plus 3, 1 plus 3, Y minus 4, -1 minus 4. And then I can figure out where my A prime is by just doing this simple math. 1 plus 3 is 4, -1 minus 4 is -5. Okay, so then I'll find A prime. That's at 4, -5, and bam, there it is right there, A prime. And you can also see that I moved it over 3 and down 4. And we did the same thing with point B. B is at -1, 4. And so we ran it through the mapping, and we did -1 plus 3 this time, and then 4 minus 4. And that gave us what? -1 plus 3 is 2, and 4 minus 4 is 0. And so we went to 2 comma 0, and there was b prime. And you can even see, again, I went over 3 and down 4. And then if you just connect those 3 corners, you get your translated triangle in the coordinate plane. In the old days, this is what we would have done. We would have just had a worksheet, and you would have sort of been counting to figure out where are the new corners. But because we're in the new days of distance learning, we did it in GeoGebra instead. And so I'll just do one of these examples, and then I'll leave the rest for you to figure out. I asked you to do 2 things on this assignment. One is to to write a mapping. So if we want to translate this 4 units up, we would just type in, well, we'll take our original x and y, like so. We have to do an arrow. So the way that I type an arrow is minus, minus, greater than, right? It looks like an arrow. So take the original x and y. It doesn't say anything about moving left and right. So that means the original x isn't going to change. It's not going to move left or right. But it does say that I'm supposed to move it 4 units up. So the original y should have a 4 added to it. So we typed the mapping in, and then we just took the polygon tool and we figured out, okay, if A moves up 4 units, it would go here. And then if B moves up 4 units, it would go here. And C moves up, there it is, right? And so then we made a transformed triangle. So you can go through and do these ones on your own. The rest of them, there's 5 more. And then one last thing that I really wanted to teach everybody with this same thing here, where I said, well, let's look at how we can translate in the coordinate plane like this. This arrow that's connecting the original triangle to the new triangle is called a vector. It shows the direction and the distance that I've moved that triangle, okay? And so if you actually want to use the translation tool to do this, you have to actually make vectors. So let's look at this one. It says we're supposed to take an object, right, and this triangle here, and we're supposed to move it 3 to the left and 5 down. That's what x minus 3 is and y minus 5 is. So you can choose any of these 3 corners. And you could make a vector going 3 to the left, but that doesn't go down 5 units. You could make a vector going down 5, but that doesn't go 3 to the left. So what's the best thing to do is make a vector that does both things at once. Go 3 to the left and then down 5. I have this diagonal arrow. And then I can choose this translate by vector. And then there's 2 steps here. First, you click on the object you want to translate, the triangle. Then you click on the vector that you want to use. Bam, it moves it along that vector. And you can make other vectors if you really want that, translate in other directions. Like I could translate this triangle along that vector. I could even translate this original triangle along that vector. It doesn't have to be connected. So I want you to try using that as well. And that was the entirety of the lesson. So try both of those GeoGebra assignments if you haven't yet. And then I'll see you in class on Thursday or Friday.